Hello, everyone, and welcome to this episode of What in the World is Dyscalculia? I'm your host, Dr. Honora Wall, and this podcast is put on by EduCalc Learning. Please visit educalclearning.com for lots of information and resources and training in the math learning disability, dyscalculia. You can also visit our nonprofit, the Dyscalculia Training and Research Institute, thedtri.org. Lots of excellent free resources there as well. And in today's episode, I want to talk a little bit about something that's a little bit of a, I don't know if I want to say a conflict or a paradigm shift that we want to discuss when we talk about dyscalculia. This is an area where I feel a lot of educators and parents struggle, and even some experts. There's some disagreement on what's the best route to take for helping students who have dyscalculia in the area of fixing or solidifying or finishing that math foundation before giving access to higher level math. And I'm sure that you're going to get as many opinions as you listen to different people on this one. Opinions plus $3 will get you a small coffee, but I'm going to give you mine. And mine is based off of my experience for many years working with people of all ages and grade levels who have dyscalculia. Typically, I work with high school students, college students, or adults, and that can skew my opinion, certainly. I have taught elementary grades in the past. It's not my forte or my skill set, and I prefer working with older learners. Anything from sometimes middle school, but mostly that high school, adult learners, and college students. So that's where most of my experience comes from. Now, I'm a huge advocate for early screening, early identification, and early interventions. Absolutely, that's going to make a huge difference. The sooner you find out you have a problem in any area of your life and you address that problem, the more progress you're going to see and the better long-term outcomes you're going to find. However, with the math learning disability, I have absolutely 100% every single time for years seen students who are perfectly capable and able to do grade level work no matter what kind of background experience they have had. It can be frustrating, of course. It can take a little longer to get done, of course. And our typical gen ed classroom is not designed really to meet the needs of these students in a lot of ways. That's a systemic problem. That's not a person problem or a learning challenge problem. Let me explain exactly what I mean, because I'm not coming down on gen ed teachers who do a lot of work to accommodate all of their students. And a lot of higher level math incorporates quite a few of the accommodations that we like to see, especially calculator use. The problem for our students is that they've had 8-ish years of training and indoctrination that the calculator is lava and you cannot touch it, and if you touch the calculator, you are not doing math. And that's just false. Mental math is a great parlor trick, and if you're good at it, fantastic. Sign up and get that free sticker they give out to people who are good at mental math. Oh, there's no free sticker. Okay, so moving on. If you're good at mental math, awesome. If you're not, you can still be good at math. You can still be a good problem solver, pattern recognizer. You can have good visual spatial skills. You can still get through algebra. You can still get through calculus. And you can still get through geometry. And you're probably going to enjoy those a lot more. But if someone hands you a calculator you've never been allowed to touch before, and the numbers didn't make sense to you anyway, then the calculator does not make sense on its own. So, in higher level math, we want to allow for a little bit of training, a little bit of walking around the room and asking students, put this and this into the calculator and tell me what happens. Tell me what you get for an answer. If they get the right answer you're looking for, then you can reinforce that. Super. Whatever buttons you hit in that order, you're doing it exactly right. Keep doing that. Now the brain has confirmation. It knows exactly what you want it to do. Check. Strengthens that neurological pathway. Check. And it continues on. If a student gets the wrong answer, then you can say, all right, let's take a look at your calculator. Maybe we need to hit the clear button 7 times. Maybe we need to look at the order. Are you hitting the radical sign before the number, or do you have to hit the number first and then tell the calculator to find the root? Are you taking the correct button and using it for a square root, or do we need one with extra letters so that you can put in any root? Or do we want an X to the squared button as our visual? Do we want X to the Y button or Y to the X button so that we can put in any kind of exponent? Does the student understand the vocabulary you're using? Take a moment to clarify that. Every calculator works differently. So if you have a room full of people using a different calculator, or what typically happens, a room full of people who never brought their calculator actually with them into the room, now you might need to answer a few more questions. If you take the time at the beginning of class to make sure everyone knows what buttons to hit in what order on their particular calculator, now we can solve a million problems, and now we can get confidence and mastery. We've removed the barrier that was in the person's way. That is a huge part of upper level math for students with dyscalculia. The earlier math that they struggled with is not something we're even focusing on anymore. We're just not asking those kind of questions. Even when we multiply and divide in upper level math, we're using some very small numbers. We're not multiplying 3 digits by 2 digits and throwing in a bunch of decimals. No, we're doing -12 divided by 2. That comes up over and over and over again. We're multiplying 3 by a whole bunch of different stuff. That's it. So the idea that you have to be perfect at the nightmare math of 3rd and 4th and 5th grade in order to do upper level math is really not true. The problem for high school and college educators is that you've got a bunch of people who have not had any math success or very little math success to rely on. So their prior knowledge reinforces learned helplessness. Their prior knowledge reinforces that this is not an area they can succeed in. That's what they're used to, and that's what they're expecting. You need to make that break. The other problem is that you're going to have a whole bunch of students coming in who seem like they don't have the basic skills that they need to keep up with you. Okay, take 5 minutes at the beginning of every class. State explicitly and directly exactly what you're going to be doing that day. Make sure everyone knows how to use their tools properly to get that thing done. And then you can have a longer conversation about the concept, about the why this is true. If you will make sure that your students with dyscalculia have success with the numbers first, then you've removed that frustration, you've removed the barrier, you've shown them that they can succeed in your class, and then they will talk to you all day about tying equations and functions to graphs and how do you interpret a y-intercept and what does it mean if you have a certain number of curves in your graph based on the exponent in your function. Then they're right there with you because you made sure that the numerical barrier is out of the way. Let's contrast that with what typically happens is that we take a student who has trouble with mental math or trouble remembering their basic facts or trouble feeling confidence, and we put them into interventions that mimic the 3rd, 4th, 5th grade situation that they already failed in. That is not a recipe for success. That is Psych 101. You don't do the same ineffective thing over and over and over again and expect to suddenly find success. That's not going to happen for students who have dyscalculia because their parietal lobe loses math information over time, and those basic facts are held almost in neurological pathways that are like gossamer strings. They're very light, and they don't fire as fast sometimes or as completely sometimes, or It's almost like watching one end of a spider web floating around, not really attached to the rest of the web. You can tell that they're looking and they're thinking and they're trying to find the numbers, and they're just not finding the other end of that neurological connection. The axons and the dendrites are just really not solid for them in that case. Okay, if we teach math, we are actually not brain specialists designed to increase neurological pathways. We can. There's a million ways to do it, and they're actually very simple, and they're going to make you happy and your students happy, but that's a topic for another day. A lot of educators got into this field not because they wanted to know about the brain and how it works, and not because they wanted to be the kind of person who spends all day enriching neurological pathways. That's not why they do this job, and that's perfectly fine. That's acceptable. Take the few minutes, make sure each student knows how to use their calculator correctly, and then move on to the next part of the conversation. Students with dyscalculia can and should do grade level work at all times. Taking an older student and making them repeat the nightmare of 3rd, 4th, 5th grade math in the exact same way they always did it before is ineffective. It's a waste of your time. It's certainly a waste of their time. And it's an external barrier that keeps students from having the success they are capable of in upper level math. So, to wrap it up, if you want to make a real immediate difference in mathematical performance for students with dyscalculia, you're going to give them grade level work. You're going to explicitly and directly show, tell, and watch them do the steps with their external tool, be it a calculator, be it a 1 to 100s chart, be it the old-fashioned times tables list, the list of multiplication. You're going to see immediate differences and immediate success. And once you give them that, then they will be with you for the entirety of the rest of your conversation about upper level math concepts. They're going to have great questions, they're going to have great insights, you're going to transform their math experience, and you're going to have a better time teaching. So, for older students, use the right intervention, use the right accommodation, break the cycle of reteaching elementary level math in the elementary level math way. And that's a great way to do it for students who are neurotypical. It's also a pretty effective way to do it for students who are struggling with a weak foundation or low numeracy. It just happens to be completely inappropriate for students with the math learning disability, dyscalculia. I'm Dr. Honora Wall, and thank you for listening to this episode of What in the World is Dyscalculia. If you have questions or comments about this episode or about the math learning disorder in general, please find me on social media, Instagram, TikTok, YouTube. We have a teacher support group on Facebook, and check out my websites, educalclearning.com and thedtri.org. You can email me, and I'd be happy to get more information to you. Thanks for listening to What in the World is Dyscalculia. We'll see you next time.